Alright, so the next video we've got leads on from the one from the momentum one. And so it's impulse. So in the momentum one, I hope you had a look at a couple of those videos. That Hewitt Druitt fish lunch one's kind of amusing, and then the one with the Swiss balls is also kind of amusing. Alright, so impulse. Okay, this is from your notes here. So already mentioned about the momentum before. To change a body's momentum, a force has got to be applied. And so often that force is a collision, a lot of the time of short duration. And so because it's short duration, it's called an impulse. So the definition of impulse then is that it is the change in momentum. So impulse is the change in momentum. Alright, so the previous thing I said about, that unless an outside force acts, the momentum doesn't change. So, and this is the case where there is an outside force that's acting, so the momentum changes. Now in symbol form, I equals delta P. Delta, of course, changing. Alright, now, so that's impulses change in momentum. Now there is, I've already said that there is a force involved, so the average that may change. And so the average impulsive force we define as the rate, that's the word in your notes, of change of momentum. Alright, and so impulse is the change of momentum, and the rate of that change is the average impulsive force. So if we look at that, then the average impulsive force is the rate of change in momentum, so it's a change in momentum, and the rate of change, that depends on the time that it takes to change that momentum. Alright, so rate's always to do with time in physics when things are changing, rate time. So the average impulsive force, the FAV, I'll write that again, is the change in momentum with time. And so if you like, we can then go two ways with this. So F average then is your final momentum minus your initial momentum over time. And of course, if we times both sides by time there, you get that F average delta T is the final minus the initial momentums. And of course, that change in momentum is impulse. So another way we can write it is that impulse then is F average delta T. Alright, so, but from that, don't forget that impulse is the change in momentum is the impulse. Alright, and so by then looking at the rate of change of momentum being the average force, you can get a second expression for impulse. Okay, so let's have a look at an example. Right, and here's an example what I was talking about before. When served, a tennis ball leaves the racket with a speed of 45 metres per second. The impact time between the racket and the ball is 5 by 10 to the minus 3 seconds. The mass of the ball, find the average impulsive force. The speed of the ball before being hit is 0. Alright, so what do we got? We need to know the change in momentum of the ball. So that's its final momentum minus its initial, and its final momentum would be its mass. Just remember, momentum is mass times its velocity. So 0.06 times 45 minus 0.06 times 0 before being hit. So when we get that, we get 2.7 minus 0, which is 2.7 kilogram meters per second. Now, we were asked for the average impulsive force, and the average impulsive force, if we go back here, the top one, average impulsive force is the change in momentum over the time. So the average impulsive force is the change in momentum over the time, and the change in momentum is 2.7, and the time, there it is, 5 by 10 to the minus 3 seconds. And when you put that on your calculator, you get 540, and of course it's a force, so it's 540 Newton. Alright, so that's it, that's impulse. Alright, so there's a couple of videos about that, and then there's some questions in your textbook. And again, as always, if there's any questions, things you need clarifying, make sure you ask.